Good morning. It is Sunday. It is the 4th of August 2024, and this is going to be a video to talk about the model uncertainties and the highly uncertain forecasts that are going to come over the next few days as a result of the developments with Tropical Storm Debby in the Gulf of Mexico and the southeastern United States. Just to point out, this video is not intended as a forecast or any one particular model evolution. It is more to discuss and hopefully open the eye to the large number of uncertainties that are currently in the forecast that are showing up in the various different model solutions, and to give you an insight into why these tropical weather systems can cause so many issues for the models. So we'll start off by looking where is Debby at the moment. So Tropical Storm Debby has formed in the Gulf of Mexico. This is Tropical Storm Debby off the west coast of Florida, a long way from Britain. And you may think, well, what on earth is Debby going to have to do with the weather over Britain over the in about a week's time? Well, potentially quite a bit. Possibly not very much at all, depending on exactly what happens to this tropical storm as it moves north. So the forecast for this tropical storm, I'm not going to go into a huge amount of detail. There are other videos on the web from experts who probably do a much better job than me than talking about what's going to go on with Debby. You can look at the videos from tropicaltitbits.com, who do a superb job of talking about what's going to be going on with Debby. But in essence, the storm is going to be moving up towards the Florida Big Bend, and then potentially it's going to either move up the east coast or it's going to stall out. And that's very much dependent on a trough, an upper level trough that's coming across the eastern United States at the moment, and whether that trough is going to be enough to pick up this tropical storm and send it northeastwards across the Atlantic, or whether it's going to stall it out across the southeastern United States. And we've seen all sorts of variations in runs over the last few days, verging from interacting with the North Atlantic jet and not interacting with that jet as it comes northeastward. So if we look at a couple of the solutions from this morning, this is from this morning's European high resolution run, and you can see the tropical storm here over the Gulf of Mexico, the British Isles in the northeast of the map over here. And you can see if we run this sequence forward, how the tropical storm kind of comes out. It's become slow moving over the southeastern United States for a time, and then it meanders around. But the important thing to note with this is not necessarily where this tropical storm is, but also what it's doing with regards to its moisture. And tropical storms and hurricanes and other such tropical systems, they have to breathe and they have to live. In essence, they suck in that warm, moist air from the ocean, and they have to vent that moisture at higher that heat moisture vents at higher levels of the atmosphere. So you will see that as it comes north up towards the Carolinas in this particular model, streams of moisture start leaving it from the eastern United States and streaming across the Atlantic. And we can see that if we look at it in another representation. We can see that if we look at the relative humidity, you can see that if you follow this moisture train here from the UK, you see it stream all the way back to this tropical storm off the US southeast coast. So the British Isles is over here, and this is the southeastern US. And you can look at, if you watch this green stream, you will see the moisture just stream forward across the Atlantic towards the British Isles. And that's why, even though this tropical storm is going to stay potentially over the United States, its impacts are going to be felt, or what happens to it is going to be felt over the British Isles with what weather we get or what we don't get later on next week. And it's highly uncertain and highly difficult to forecast what exactly is going to happen, depending on how much moisture streams northwards, how it interacts with the jet stream. So the jet stream is in a position over the North Atlantic later this week, which favors any perturbations or low-level breakaway low pressure centers forming and moving over the Atlantic towards the British Isles. So it gives forecasters and it gives people like me a little bit of a headache as to what exactly is going to go on over the British Isles and Northwest Europe later next week. Is it going to interact with that jet stream? Is it not going to interact with the jet stream? Are we going to see areas of rain coming northeastwards, or is the jet stream going to buckle enough that it sends warmer air northeastwards across the British Isles? So there's a various number of solutions that we come to look at. So if we look at the how the GFS is going to look at this from another perspective. So the GFS, if we look at this as another representation of the same model. So this is where this is the cyclonic vorticity, the spin of the tropical storm in the atmosphere at the moment. The grey lines are the 500 millibar flow, and if you just see here, the wind barbs are the 200 millibar jet stream. So this combines the low level kind of spin of the atmosphere, the mid level flow, and also the high level jet wind all in one chart. So if we run the sequence, again, we see the tropical storm come northeast into the northeastern Gulf of Mexico. In this particular run of the GFS, it stalls it out over the southeastern US. So you see it doesn't particularly move very fast, very quickly, and produces a very big flooding threat for the southeastern United States. Something in the region of around, I think, 20 inches of rain potentially falls across parts of Florida, Georgia, South Carolina, and North Carolina in this particular model run over the next week to 10 days. But also, and perhaps more importantly, you can see here and around, even though the storm is over the southeastern United States, the jet stream is being pushed south by a big cold outbreak of air moving south from Hudson Bay. And there is a fairly substantial shortwave trough coming south across the Great Lakes towards the end of next week. And the vorticity, or the spin, or the energy in the atmosphere from this tropical storm, if you watch carefully, you can see some of these red areas of vorticity get sucked into the jet stream. And that is important because if we look at the jet stream by itself, you will see, if I go back here, the jet is this is around midweek. The jet is fairly, again, flat near 50 degrees north, but we have a strong input of cold air into that jet from Hudson Bay, and we have this tropical system over the southeastern United States. That is not a good recipe if you're looking for a weak jet stream to develop over the northeastern United States. And if we run the sequence, you will see that as that tropical energy, forget the actual center for just a moment, the energy from that tropical system is going to be pushed into that jet stream, and you can see that here. And by the time we get through to Saturday, that jet is invigorating over the northeastern part of the United States, over Newfoundland, over Nova Scotia, and that jet is up to around 150, 160 knots by that time. And then it moves across the Atlantic towards the British Isles. And in this particular run, this is going way out now. This is going 210 hours out, so it's a long way out, but it does show you the potential for a very deep area of low pressure to form in the Atlantic, 966 millibars on this particular run, which, if we have a look at the ensemble, there it is to the west of Ireland, you can see that is an outlying run. There was no other particular model solution. However, there were other solutions that went down to 983 millibars. There was another one there that went down to 983 millibars. One there went down to 987 millibars. So it does give you some indication that there is some potential for a fairly active jet stream and a fairly active jet pattern to come across the British Isles as a result of moisture from this developing tropical storm over the southeastern United States. Now, the European model is again in a similar vein, but things are changing run by run. A couple of runs ago, the ECMWF and its ensemble members were largely keeping the precipitation over the southeastern United States. Today, if we look at the model runs, the storm is ejecting off the northeastern coast of the US, and that's because in this particular run, there is another shortwave that is coming northeast. So the area, the storm finds its way northeast, and then we find that there is enough shortwave energy coming off the Great Lakes to pick up that remnant storm and send it across the Atlantic. But all the time, regardless of whether it develops and develops an entity of a storm of its own over the North Atlantic, the energy is being pushed into the North Atlantic, and that is likely to produce some real forecasting headaches for us over the British Isles over the coming week, as to whether we see flabby areas of low pressure with outbreaks of rain moving northeast, or whether we see a buckling of the jet stream and we see some heat. So it's perfectly possible that we see some heat being pushed northwards from this, and you know, we see the risk of some thunderstorms pushing northwards as well. That was seen in the in today's GFS. You can see here that there's some a high pressure develops, and you can see that a big plume of heat comes north across the British Isles, or at least the southern and eastern part of the British Isles. And then we see a deep area of thundery low pressure moving north. That's perfectly a possible solution. We've seen on the UK Met, we see a very different pressure pattern. We see the Atlantic really quite broad. We see areas of low pressure. If I choose the right model there. We can see the low pressure stays northwest of Scotland, and then we see another. This will be the ex-remnant of Debby here, coming in on the western side of the chart here on the UK Met. That would be the ex-remnant of Debby. So you see here no real build of pressure, no real heat across the southeast, and what the UK Met would do is probably have fairly weak, flabby areas of low pressure coming towards the British Isles, and then have a more invigorated low centre that you see there coming into the west of the chart. And if you look at the European high resolution, again, it's a different solution. Once again, you've got the broad, moist southwesterly flow with moisture streaming northeastwards from Debby, which is what we saw here on this graphic. Again, we can look at it here. You can see the moisture streaming northwards from Debby. If you watch it here, you can see Debby's off the US East Coast. This moisture is piling northwards from Debby around this big Bermuda high. We have a huge Bermuda Azores high at the moment, anchored across the Atlantic, and that is largely blocking anything from coming northwards across the central Atlantic. So everything is being steered up around that Bermuda Azores high, and you can see that moisture then comes streaming across the Atlantic towards the British Isles. But there's no real significant low development at this time. These frontal perturbations are all largely on what we call the warm side of the jet. So the jet is anchored right here. The frontal perturbations are also anchored here. So we see most of the outbreaks of light rain, perhaps some drizzle, reasonably quite humid air, all stemming from this tropical storm that's anchored at this time over the Carolinas. And you can see that storm then comes northeastwards in the European model. It then develops more intensely. You can see that dry air wrapping into that. That's a sign of more intense cyclogenesis taking place, where it is interacting on the cold side of the jet. You get a deep area of low pressure forming in the European 964 millibars. So similar to the GFS in some ways. If you look at the GFS for that time, you can, well, that's the new run coming in. If you look at the GFS for that time, again, you've got a similar 962 millibar low there. It's to the southwest of Ireland. The European model was to the further northwest in the Atlantic, but all indicative of potential for some very interesting weather, some very uncertain weather to come across the Atlantic, and we are going to have to pay close attention, because these model runs are going to be changing quite frequently from time to time as we see what's going to happen with Debby over the next few days. An interesting week to come. And that's it from me for now.